Today we're going to look at a gadget that Radio Shack sold called a Mobile Alert, which was a silent alarm for your car. A great way, to interrupt someone trying to steal from your car just so you can get yourself stabbed or worse.
Back in the, I guess it would be the mid-'80s or so, when people started putting higher power stereos in their car, and that attracted theft. People would get their, I worked with guys that would spend thousands upon thousands of dollars. I worked with a guy there back when I was at the TV shop. One of the guys that worked in the shop, I forget how much he spent on his car stereo, $5,000 or $6,000 or $7,000. It was crazy the amount of money. The stereo in his car was worth more than his car. He was driving an old Honda, and he had the stereo that was worth more in his car. And what people would do to try and protect the stereo is they'd put an alarm in. But an alarm only makes noise. So what Radio Shack came out with this little device called a Mobile Alert. And what the Mobile Alert would do is it would broadcast a radio signal using your car's antenna, and you carried around a little pager, and if your pager went off, you went running back to your car to catch someone in the act of ripping your stereo out so that they could shank you with a screwdriver. And that's exactly what happened, by the way, to one of the guys that I work with. He interrupted somebody who was ripping his stereo out of his car, and the guy's buddy that was hiding shanked him with a screwdriver and missed his aorta by about 1 centimeter. He came within 1 centimeter of dying, all over his car stereo. But anyway, true story. And I won't say his name, but yeah, he was in hospital for a while, and it was a wake-up call that you don't want to disturb someone who's intent on ripping you off, because you don't know what weapons that they're going to have. Anyway, this is one of these Mobile Alert devices. I figured we would tear this thing down to see what makes it tick. Basically, it's a transmitter that transmits on the 27 megahertz CB band, but they operated on a frequency that was not in general use for the CB radio service. Although everybody had those channels in their radios anyway, they called them the half channels. Is where they transmitted. So I figured this one here, we're going to tear this down and just take a look at what makes this thing tick. I don't have the pager that goes with this. I did have it at one time, but the pager is, I don't know where the heck it is. Anyway, this is what you did to set this thing up. There was a series of switches, dip switches inside. This one might have been the digital one, actually. There was 2 different ones that they offered at one time. There was a cheaper version which just used tones to send off to trigger the pager, and of course that one, people whistling, they go or whatever. People would whistle on their CB radios, and that would trigger the pagers. If you knew what the tone was, you could whistle the 2 tones and it would set the thing off. So then they came out with a better one, and I think this is the one that was digital coded, but we'll see. Let's just take a look at how this thing works. So on here you've got siren wire to a pin switch, so you can have it hooked up so that when your door light came on, it would turn it on. And then they had 2 micro transducers, which were basically a contact microphone. They were just a piezo type device, the same thing you can see as a piezo buzzer, and you glued them down to your door post. That way they would detect somebody trying to jimmy the door. Even if someone came up and pulled on the door handles, it would set it off. 12 volts power. Then you had a ground wire, and you had the power lead, which was orange, which is number 6, and the ignition switch so that it would turn this off when your car was turned on. And then of course the antenna plugged into here, and then the lead from this one went to your factory radio or your stereo. This one here is 4 watts, so this was the higher power system, because the original one, I believe, was 2 watts. This one transmitted at the full 4 watts. And as you can see, this thing's never been opened because the screws here, they've never had the rubber caps popped out of them. So let's just open this thing up and see what's inside this unit. I don't know, I think this unit probably does work, but to say, when I bought a car once, and there was already one in it. It was back when I was still buying used cars, and this was already in it when I got the car. And I took it out because it was always going off, or it wouldn't go off is what it was, because there was so much interference on 11 meter band, 27 megahertz. This was also useful as a one-way pager. You could use it as a pager to page somebody. Press the button, it would trigger the pager. So the two screws out of it, and the unit just pops apart to show the transmitter. Here's our RF amplifier over here. See if I can get the board out. Yep, there's the board out of this one. So this is the unit. It should be a crystal control transmitter. There should be a crystal in here somewhere that sets the frequency, and here's the crystal here. Let's take a look at what frequency this one is. Looks to be 27145. Anybody remember what channel that would be? What would that make it? 15A? Channel 15A? Anybody? It's been a long time since I had anything to do with CB radios. I forget the frequencies, but anyway, I think it was 15A that where it was residing. But we can actually power this thing up and see what it transmits. We'll pick this up with my digital DSO, and we should be able to get a capture of this thing. But here, you set your dip switches on this one. So it was I guess it was an 8-bit code that it would send out, and if the code matched the receiver, it would trigger the receiver. Now this thing hasn't been powered up in eons, so let's see if I can get this thing to power up and see if we can get a signal out of it. That would be kind of interesting. See if we can get a signal out of this thing. Uses a 2SC2166 is the output transistor on this one. Let me hook this up to the power supply and see whether it will actually send a signal. So I've got my power hooked up to this unit. Let's try powering this thing up and we'll see if we can get a scope capture of the signal radiating from the antenna. So this thing's not under load, so I don't want to run this thing too long because it'll probably overheat the output transistor. That's if this thing even works. I don't even know if this thing works. So let's give it power and see whether we get any signal. I gotta let this thing boot up. Now when I press the button on the front here, this thing should transmit and I should see a code, or I should see RF on my scope. So we trigger this thing by turning it on, and I see a signal on the scope. So there's what it's transmitting. Great. It's transmitting a coded signal that would be transmitted over the car antenna and received by the pager. We'll trigger it again, make sure this thing's not getting too hot. Nope, no heat. So I'll trigger it again. As you can see, it's a relatively low coded signal representing, and it just repeats the code over and over again. So that's one burst there. Unfortunately, this digital scope that I've got doesn't have very good resolution. I'm wondering if I can actually view it on my analog scope and see whether how it looks on that one. So we'll try that. I'll just hook my analog scope up. So here's the analog scope. We'll trip it. I'll probably have to dial down the yeah, you can actually see more on the analog scope. So basically it's transmitting short and long bursts of RF energy. As I say, my digital scope just is not good enough. But you can see it there, right? The pulses. Put this in the right mode here. That gives you probably a better idea right there. And if I flip those dip switches to a different code, it will give out a different code. So let's just turn them all. Let's turn them all off. Yeah, now all the dip switches are off. We'll trigger this thing again. And we'll see if the code looks any different. And then I'll turn them all on. Once it finishes its sequence, we'll turn all the dip switches back on and observe the waveform and see if it's any different. And if I'll turn them on, off, on, off, on, off. Try this one. This works like the old garage door openers, right? Exactly the same, but a garage door opener uses a 345 megahertz frequency. This works on 27 megahertz. So now, I don't know how it's coming over on camera, but on the actual scope display, I see a different signal. And if I look at the digital one you can actually kind of see a code. It's hard to see on this because there's no storage. The digital one, you can kind of see a code. Let's look at the digital scope again. So here's the switches. On, off, on, off, on, off. You can kind of see the code, right? This is the code. The spaces between them. Everything's all in one burst there. And if I were to turn them all off, the next one I'll turn half them on and half them off. You should be able to see a little different code. Okay, so here, trip it now. See the difference there? The difference in the pattern? So that's all the switches are all off. And if I do the same but I put them all on, so now the first four are off and the second four are on. My ground came loose. That's why you were seeing all that noise. So that's 4 switches on, 4 switches off. And I'll flip them all back on again just because I think the last reading was erroneous because of a bad ground. Okay, so here's all the switches on. See the difference? And if I start turning them off, I don't know if it does it in real time or whether it has to wait till it cycles. Now they're all off. And if I do it one more, I'll flip 2 of them on, 2 of them off, 2 of them on, 2 of them off. So there's 2 on, 2 off. And as I tweak them as it's running, I'll put 1 on and the rest off. So this is switch number 1 on, 2 through 8 is off. Anyway, you get the idea. you get the idea how it works. It just sends out a pulse, just turning RF on and off. It's just sending out a pulse. This was a little more reliable than the earlier one, which used two tones, because the two tones received a lot of interference. So this one here actually had much fewer false alarms. That's if you were within range. The big problem with, of course, devices like this was they were on the 11 meter CB band, and there was a lot of people that were running high power amplifiers on that 11 meter CB band, and they would overpower these. So even though it was a digital signal that was sent to the pager, there was a very good chance that you would not get that page because there was so much interference on that band that it made reception impossible. But that's the basic unit itself. As you can see, it's got a couple of MC 1401B chips in it. It's actually got two MC 14001B. There's two of them here, and it's got an MC 145026. This would be the encoder for the digital, I'm sure, because that's what's hooked up to all the switches. So this is the one that's generating the data pulse stream, and that is likely the same one that was in garage door openers of the same type of design with the switches. And it'll have a couple of amplifier. This is probably the op amp over here to pick up the signal from the little contact microphones that were mounted on the door. This is the transmitter over here, just a crystal controlled transmitter, and it's pulsed on and off from this chip. And that's pretty much it. Not a lot on this thing. The circuit board here. Anyway, this thing is completely useless. If I found the pager for it, it might be useful, but I have no idea where that is. So this unit is now going to, I don't know, probably send this thing off for recycling, because I really don't have a need for anything like this. As I say, these were popular back in the 80s when guys would spend more on their car stereos than their car was worth. And as I said before, I knew a few people that did that. Actually, I knew more than a few people that did that, but one guy took it to the extreme. I'm sure people still probably put in some pretty fancy stereos in their cars. But the thing is, with the modern cars, that's become a little more challenging, because, of course, everything modern now has an infotainment center that's built in, and of course the factory radios now in cars are so much better than they were back in the the 70s and 80s and 60s and 70s and into the 80s. The factory radio that came with a car was usually pretty I'd like to call it a pile of crap. Even the so-called premium sound, I don't think were that great in many cases. That all changed. That all changed in the late 90s. I think one of the new cars that I got, which I still have, is going to be a collector's car someday because there's not too many of them around. It came with a cassette deck, but it came with, I think, 40 watts per channel, and it actually didn't sound too bad. But now the vehicles I drive now, they all have these infotainment centers in them. They actually have some pretty good sounding Bose factory radios, factory systems now that nobody in their right mind is going to break into your car to steal a factory radio. So these things are kind of redundant now. But anyway, I thought you guys might like to look inside and see how one of these things kind of works. And that's about it. We'll catch you in the next one real soon. Bye for now.